Hey, hello everyone. Welcome to the LD4 2022 conference, Linking Global Knowledge. My name is Jim Han. I'm the session facilitator. Before I introduce our speakers, I'd like to highlight just a few resources of interest for our attendees to help you navigate the conference. We do have a conference website and contained within there several important links. One I'd like to draw your attention to here is the code of conduct. So from that page, and I dropped the link in the chat, you can both read the conference code of conduct, but also there's a link there that will allow you to report any violations of the code of conduct. We want to make sure we have a open and inviting conference for all. We are using this hashtag LD4 2022 if you have conference tweets. We're also able to offer technical assistance during the conference by way of our conference Slack. The invite link is in the chat there. We will have a channel there for tech support. So if you also want to use that for continuing the conversation for any session here this week, you'll find channels in the conference Slack for that purpose. So just a final reminder, our sessions are either recorded or we're streaming them to YouTube. So you'll be able to view the recordings later, and they'll all be on our LD4 YouTube presence. So there's the link for that. And then this particular session is also being live streamed. With that being said, I'll now introduce our speakers. We have 3 speakers today. Greta Heng. Greta Heng is Cataloging and Metadata Strategies Librarian at San Diego State University. Her research interests include linked open data, semantic web, identity management, and information search behavior. Our next speaker is Sheetal Rani Prasad. Sheetal is a graduate student at San Diego State University, majoring in computer science. She has a background in web application and microservices development. Her current interests are machine learning and data engineering. Andre Hewlett is an MLIS candidate at San Jose State University. He has a background in information technology, and his current areas of interest are metadata management and information search and retrieval. So with that, I will turn it over to our speakers. Thank you so much.
Thank you, Jim. Hello, everyone. Thanks for joining us. My name is Greta Heng. I'm the Cataloging and Metadata Strategies Librarian at San Diego State University. Today, I'm going to present our Wikidata project with my 2 student assistants, Sheetal Rani Prasad and Andre Hewlett. Sheetal is a graduate student at San Diego State, majoring in computer science, and Andre is a library information science student at San Jose State. Our Google Slide link is provided in the session description, and I also put it in the chat. The focus of today's presentation will be our faculty profile Wikidata project. We will start with a brief introduction about our project background. Then I'll talk about tools we used, data model, and our project workflow. Sheetal will give you a demo about how we automate the majority of workload of creating and enhancing items and statements in Wikidata. Andrew will then show you how we do some final touches and enhancement for faculty Wikidata named entities. We will also discuss some challenges we have met and our future plans. First, some background about this project. SDSU Library participated in the Program for Cooperative Cataloging PCC Wikidata Pilot Project in 2020. From 2020 to 2021, our library launched 2 Wikidata projects. One is SDSU Institutional Data Project. The other one is Special Collections and Archives Project. For the SDSU Institutional Data Project, my 2 colleagues worked on this and have built basic data models for faculty, colleges, departments, and buildings. They created 42 SDSU faculty Wikidata pages and described some colleges and buildings in Wikidata. The goals of this project were to encourage catalogers and metadata creators in the library to explore data and Wikidata and improve the visibility of San Diego State University institutional data, especially faculty, researchers, departments, and centers. In early 2022, I took over this project and received SDSU seed grant. When I started this, I talked with subject librarians and people in the digital collections and digital humanities to understand their thoughts about this project and think about the new values and new goals. I learned that in 2021, although SDSU has an institutional repository, there had not been a scholar profile website or a controlled name list for SDSU faculty. This issue influences the discoverability of resources in the IR because faculty's name showing up in the IR may have different formats, for example, with or without their middle name. Digital collections also, they were building a spreadsheet for faculty name that appeared in the IR, and they wanted to have a more complete faculty name list. Many colleges and institutions like College of Arts and Letters had also reached out to the library before and wanted to collaborate with us to promote their faculty works. SDSU Division of Research and Innovation wanted the library to help collect SDSU faculty open researcher and contributor ID, ORCID ID. However, SDSU library does not have a dedicated scholarly communication librarian, and we did not have a database for ORCID or any type of name authority IDs for faculty. By continuing this wiki project, I will collect the faculty name authority IDs like their Library of Congress name authority IDs, Virtual International Authority File IDs, and ORCID ID, while building up their profiles in Wikidata and build the foundation for the library's scholarly communication. I decided to create Wikidata IDs only for tenured, tenure track, and emeritus faculty who have publications and potentially have name authority IDs in other platforms. Many libraries have done similar faculty Wikidata projects, like Vanderbilt University's Researcher Wikidata project. Vanderbilt's project used Wikibot to edit Wikidata items in batch and exchange data between Wikidata and Wikibase. Their project inspired me to look deeper into Wikibot and think about how we can utilize this tool to optimize our faculty Wikidata project workflow. For those who are not familiar with Wikibot, Wikibot is a software that can make edits in Wikidata via an API. If you want to use Wikibot, you have to apply for a bot account. Users will need to submit a request to the Wikidata community like this picture shows. The bot admin team will ask you to do some test edits and provide some feedback about your bot account requests. Follow the instruction on the link at the bottom. You will be able to have a key for your bot account. The key and the bot account information are needed to set up PyWikibot. PyWikibot is a Python library that allows you to use Python to interact with Wikibase and Wikidata via a Wikibot. You need to log into your Wikibot account every time you use the bot through PyWikibot. Compared with other Wikidata batch editing tools like quick statements, PyWikibot allows you to define the relations between each column. And you can also choose your own input type. It doesn't necessarily to be CSV or Excel. All Wikidata editing is running in the backend. So this tool will give you more flexibility, more control, and better efficiency. Another tool we use is OpenRefine Wikidata reconciliation services. We utilize Selenium Python API to set your fingers free from mouse clicking. This API will open OpenRefine and run the reconciliation services for you while you monitor the program running. Here's a table of our data model. We put the basic description, core statements, and some commonly used extended statements here. Most statements can be made using Wikibot. For occupation and official website statements, tenured and tenure track faculty will have different values from the retired faculty. There are 3 phases for our project. Phase 1 is data collection. We scraped SDSU departmental website to gather some basic information about our faculty. Those brief information about faculty is easy to scrape using Python, and is good enough to create a brief Wikidata entity. Phase 2 is data preparation and batch editing. We clean and normalize the faculty data we get in the Phase 1, reconcile their name in the string format against LCNNF and Wikidata name entities. Then we use Wikibot to create new Wikidata items and statements in batch. The last phase is menu enhancement. In the last step, we look for faculty's name authority IDs, link their Wikidata page to their notebooks, and add other appropriate statements. We first ensured that each college and department had their own Wikidata entries and collected their Wikidata queue numbers. Then we went to each department's website to collect faculty information and generate 2 CSV files for each department, one for tenured and tenure-track faculty, one for emeritus faculty. This is because the website divided them into 2 sections by design, and the data model for those 2 groups are slightly different. We used a Python script to collect faculty's name, title, education background, and their highest degree if those information are available. We also collect their departments and college name. I will now turn it over to Shitol. She will walk you through the second phase.
Thank you, Greta. So the phase 2 of the workflow consists of 3 steps: data cleaning and preparation, data refining, and finally creation of Wikidata items. We developed a web application for SDSU library. Let's go through the demonstration of this application and see the workflow in detail. The faculty's primary data is collected in first step. The Wikidata ID of college, field of study, and department is collected. The base URL of the website is taken to set the faculty web page column. We upload the Excel of the scraped data and start the process. These data are added to the faculty list. The script further looks up the LC based on faculty's name string and adds the result of the suggested list. We chose LCNAF because it is one of the most widely used name authority files in the libraries. In the next step, it is to reconcile data with Wikidata using the OpenRefine program. We are using automation here, which results a faster interaction speed compared with manual selection. The data is loaded and formatted in tabular manner. OpenRefine with Wikidata reconciling extracts and assign data that is closely connected to the field mentioned. For example, the degree is reconciled against the Wikidata link and matched to the closest PhD entry. But we want Doctor of Philosophy, therefore we edit this selection. After that, we map it to the appropriate queue number, which is the Wikidata ID of the selected item. The process is similar for school's name. The match is reconciled and manual correction is performed when needed. Multiple items can be matched to one value. To select appropriate name, refining is necessary at this step. Here, ASU is perfect match. We don't need to do anything with it. But we see that University of Southern California has many matches. We need to select one from the list of suggestions. We then add new queue number column for the school. Afterward, the name of the faculties are processed. Our script matches the faculty name against Wikidata entities in the Q5 human class. This reconciliation may take some time depending on the number of data rows. Next is the Library of Congress Authority ID. This may have many proposals that need to be reviewed, and only the number that matches individual perfectly should be maintained, and remove the ones that do not match. Wikidata has format constraint on LC Authority ID, hence we edit and keep the ID numbers only. We need to double check on all the people that match to the faculty names are appropriate. Again, the item from the suggested list should be reviewed and best match needs to be selected. For no match items, we select create new item. There could be a perfect name match with Wikidata, but it might not be the person we are looking for. We check and edit the selection as required. Then we add Wikidata IDs of these faculty items and name the column as FQ now, which is reflect the existing IDs of the Wikidata entry. entries. Once finished refining, this table should now be exported as CSV for the final step. Finally, in the item creation stage, the script adds statements in the Wikidata record. Our script checks for duplicate values and apply qualifiers. One function is for tenured academics, while the other is for emeritus faculties. Using Wikibot, we create a structure for these new items with data of the faculty. Following that, it builds a page for each row that lacks Wikidata entry. The Wikidata name entity ID of freshly added items is returned by the script. A file is created with all the data that was available in step 2, and new Wikidata IDs are added to the respective record. We can open the record for each new created item and check the statements added under it. For already existing items, we append new statements to reflect SDSU faculty data. These existing statements are not impacted in this process. In summary, here we can see how the initial CSV file evolves. Image 1 is the newly scraped data. Image 2 shows the required field IDs, LC suggestion, and website data added. Next is refined LC values, addition of Wikidata IDs of the degrees, school, and existing faculty entries. And in the last CSV, we can see that the appropriate Wikidata ID are added under FQNum column of the newly created items to access these entries. Andre will now take you to phase 3 of the workflow.
Thanks, Sheetal. I'm going to begin with some general remarks about the manual enhancement process. This phase combines new manual enhancements with the verification of pre-existing data from the Wikibot or other prior manual enhancements to faculty profiles. Most often, the source information for additional enhancements comes from the SDSU faculty members webpage, where high-value information such as educational history and notable works is difficult in some cases to extract automatically. The Wikidata entry tools make it easy to move from strings to things to control and speed up data entry. When the cataloger simply types a needed word or phrase into a property or item field, an ordered list of defined entities filtered for the field in question pops up for selection. Additionally, the faculty enhancement lists extracted from Wikidata in phase 2 simplify the cataloging process by providing hyperlinks to each Wikidata page in question. Since the Wikibot has already entered the faculty member's webpage link into the Wikidata record, you can quickly load the needed sdsu.edu page as well. Our process starts with the enhancement list itself, organized by academic department. Any issues encountered with the enhancement are recorded and worked out here. The cataloger opens the given Wikidata page and verifies the standardized core data already loaded by the Wikibot, which you can see there on the left of the slide. We've seen only a small number of issues in this step, so it goes very quickly. Occasionally, the Wikibot encounters a pre-existing Wikidata page for a faculty member. These profiles sometimes need minor fixes, such as enhancing the preferred official website if there ends up being more than one. The cataloger then reads the faculty summary to gather more specific information not already extracted data. The style of the summary can vary quite a bit by academic or even by department. The faculty member will often list additional field of work specialties, such as an anthropologist who also focuses on ecology, or occupations, such as an academic center directorship. The most common information that maps to our data model revolves around names, given and family, notable works, and education history. Occasionally given names and family names do not already exist in Wikidata, so they must be entered as entities before they can be recorded. Historically, many of the notable works in Wikidata have been recorded without reference to the author's profile. We correct this problem by adding a direct link to, from the faculty member's article or book entry back to their profile. These omissions can take significant time to correct, depending on the number of notable works recorded in Wikidata for a given faculty member. With the less common enhancements, namely member of, awards received, nominated for, and by member of, I mean organizational membership. Entries for organizations and award names often don't exist, and we've elected to hold off entering such values for now. There are a few data model terms that we encounter only rarely, and in the case of date of birth, we chose not to enter out of privacy concerns. In the final enhancement step, the cataloger creates links to several researcher registries for the faculty member. In over half the cases, the Wikibot has already entered the Library of Congress LCNF ID, and we seek to include at a minimum the VIAF and ORCID identifiers as well. Additionally, many SDSU faculty maintain profiles in academia.edu, Google Scholar, and ResearchGate. While these links help validate identity, they also contain other biographical information and lists of works, including many that aren't recorded on Wikidata. Due to the variation in style on the SDSU faculty pages, it's possible for the cataloger to end up with only a few enhancements to add to the profile, or in a few cases, I had no enhancements to add. In these cases, alternate sources can provide valuable information, and it's usually worth examining these sources for the most common enhancement elements. For instance, we can see here that Joanna Brooks, her MARC record is available at viaf.org. It contains her educational history. She also has a personal website and an academia.edu page, all of which helped round out her Wikidata profile. This approach, of course, complicates the enhancement process. However, because the cataloger usually has to visit sources like these anyway to obtain other enhancement values, it becomes a matter of remembering to go back and enter, say, educational history, even if it's now out of the typical workflow order. Our effort to automate and further standardize the profile creation process has exposed several challenges so far, and I'll list them here on this slide. Regarding reconciliation challenges, we had hoped to use ORCID ID as a primary name authority reconciliation, but SDSU faculty apparently use ORCID less than we had assumed. While we often find an ORCID record for a given faculty member name, it is sometimes blank with no contextual information to validate that the record refers, in fact, to the same faculty member. As I mentioned, SDSU faculty use other registries like academia.edu at least as frequently as ORCID. Then there's the matter of manual work, that we've been able to obtain much of the information specified in our data model. The amount of retrieval outside of Wikidata comes at a cost. Not only are there more websites to examine, it's less clear when to stop looking for a specific value. For instance, how many sites should I go to find an education history? We also need more Wikidata entries. It would be possible to create richer, more easily consumed profiles, more supporting entries for notable work, organizations, and awards already existed in Wikidata at the time of profile enhancement. These absences also slow down the manual work, since the cataloger has to check Wikidata for the article, organization, or award in question. When it doesn't already exist, the in-process entry for that information has to be discarded, and you move on. Lastly, some Wikidata ontology support would be helpful in a couple of instances. The number of terms and logical constraints in the Wikidata ontology is, of course, immense, but we have found a couple of issues worth pursuing. Though we decided not to enter date of birth or gender, it's notable that date of birth has a constraint that flags the profile if gender is not entered as well. The value of this constraint is unclear to us. Additionally, there appears to be no way of specifying that a given name or family name is hyphenated. Since name hyphenations are usually unique and used for a variety of reasons depending on cultural context, it usually doesn't make sense to create a new hyphenated name item because it won't be reused. In our case, if there is no pre-existing entry for the hyphenated name and no evidence that the name is hyphenated by convention, we enter two separate values for each part of the given or family name and use the series ordinal property to indicate which name should come first. Now I'll turn it back to Greta, who will provide an overview of our future work.
Thank you, Andrew. So looking into the future, we will continue this project and collaborate with digital collections to find more opportunities of linked data implementation. Our digital library will migrate to a new system that has linked data function. We will explore Wikibase with them and test using URIs and other linked data features to improve the discoverability and accessibility of some faculty collections. The ultimate goal is illustrated in the picture. We want everything related to the faculty in the library can be linked together in the digital collections. Another thing we would like to work on is improving our workflow. For example, using ORCID API and VF API to automate ORCID ID and VF ID searching. And writing maybe another Python script to do some automations for linking Scholar and Scholar works in Wikidata. Thank you, everyone. Now we come to the end of this presentation. I put our GitHub repositories link here. One is for web application that Chito developed for this project. One is for Wikibot Python scripts. We also listed our emails here. If you have further questions that we don't have time to address in this session, please feel free to reach out to us. Thank you. I'll stop sharing.
Thanks so much. That was really exciting, really great to see the collaborations and the great work that was done. And just, Libby, do you see any questions we want to bring up?
Yeah, we just got a question asking if you could put the GitHub link in the chat. I know it's in the slides. So that's one question. The next question we have is, have you noticed if your additions to Wikidata have helped populate Google Knowledge graphs / panels and or wiki pages or other sites?
You mean the knowledge graph, the visualization? Yeah, we noticed that, and Andre actually helped to create some Sparkle queries for that. But since our focus today is the workflow, we didn't present it here.
Okay, our next question is, if you have choices to decide which department to use in this process, which one would you pick as a test base? Social sciences, humanities, or others?
This is a good question. We started with the College of Arts and Letters because the department reached out to us to see if there's some possibility of promote their faculty work. So we started with this college first. That is our case. And my suggestion is maybe start with a small college if you want to try this tool. And you can also revert the Wikidata editing process. You can redo the things you added to Wikidata if you found something wrong with the Wikibot or the scripts you are using.
Great, fantastic. If anybody has any questions, please feel free to put them in the chat or put them in the question and answer section. I'll give it a few more minutes for those who are typing. I know how hard it can be when you're typing a long response. So if you're typing, we'll give you a few minutes.
And maybe I can ask a question I'm curious about. Do you have other, are you exploring or have you thought about other sort of ways to visualize the data that are created now in terms of next steps?
So Andre, do you want to respond to this question?
Well, I guess I'd lead by saying I want to get some good ideas, or we want to get some good ideas developed for how to visualize the data. Our initial Sparkle queries are looking at the relationship between notable works and authors, and that there are also, you can look at statistical relationships, such as the number of how many notable works can you find on Wikipedia by faculty member. Faculty members who may have a specialty such as women's studies, but be in different departments or schools within the university, being able to find all those academics who are working in women's studies, for example. So those are some of the things we've come up with initially. My fantasy is to figure out like a geographic visualization, but nothing's occurred to me yet. So if anybody has any ideas, put them in the chat.
Perfect, thank you. Oh, okay, so we have a few more questions coming in. I also just wanted to reference the fact that Greta put into the chat a reference to the slides. So New York University has a similar faculty identifiers project. We too have experienced the reconciliation, disambiguation challenges with some namespace platforms, in particular ORCID. Some ORCID entities are marked as private too, which makes it difficult to confirm whether you have the proper person or entity. So that's a good feedback for that. Does USDSU use a homegrown IR platform? Do you find it easy to link the faculty profile to Wikidata?
Thank you, Cindy, for this question. So I mentioned that we are migrating our systems. We're now using Alendora. So Alendora does not support any linked data features for our version. We are migrating to Archipelago, which is a new IR platform, I think, and it allows us to add Wikidata IDs and LC-NNF ID in the metadata records for those collections. So it will be easy to add the Wikidata link to the record in the future.
Perfect. Thank you so much. We've got some kind of follow-up questions, not questions, comments in the chat. Jim shared some links for customization, and I believe Allison said, if you have any fiction writers, narrative location of work is an option for geographic visualization, or if you have where they were educated, you can map that.
Thank you, Allison, for the suggestion.
And then we've got another comment from Steve, who said that Stanford Libraries also has a well-documented project page, and he provided a URL for that. Any more questions?
I saw there's one in the Q&A part. The question is about privacy. Yeah.
So thanks for your presentation. We're also working on adding faculty into Wikidata, and part of that project involved discussing privacy and/or consent considerations around adding faculty data into a linked open data platform. Did you have any conversations about this topic?
So I saw there are some presentation about the privacy issues in the last LD4 conference. So for us, we didn't put like the date of birth, the gender information, those kind of private information into the linked open data platform. We only put the information we got from the SDSU departmental website. You can find those information directly by going into our website. And actually those information we got from the faculty. They send those information to the IT themselves. So we thought that was okay. And for Andrew's enhancement, he is gathering their author IDs and those publicly published notable works to the faculty webpage. So I think that is okay for us for now, but as for maybe the audience have some suggestions or thoughts about our project, please share with us. I would like to hear your feedback.
We still have plenty of time for questions. If anybody has a question or if they want to share a comment. Okay, well, this is my final call for questions. But I think that was a wonderful presentation. Thank you.
Thank you, everyone.
Thank you, everyone.
Everyone, have a great afternoon.